Hello, everyone. Good morning, good afternoon, good night, good evening, good whatever it is, wherever you are. And welcome. Big news for us today, and that's kind of why we're here, is to talk a little bit about what's been happening at Wherobots, and some of the big news today. So I know there's a little suspense in the title and thumbnail before we got started. But today we're very excited and proud and happy to announce our Series A funding round. And it's I think it's big news for us at the company, obviously, and a lot of work that went into this, and kind of to talk about a little bit about what all this means and where we're going. And today we'll hear from Mo and Gia, the two founders of Whereabouts and Apache Sedona, to dive into that. And we'll also talk with John Powell, who's one of our customers at Whereabouts, and kind of hear from his experience what he's been able to do with the platform and things like that. But just kind of get a kickoff to things, and kind of cover some logistics. You should have access to the chat. If you have any questions or comments, don't hesitate to drop that in. We'll be tracking those across YouTube and LinkedIn. So go ahead and drop those in. If you want to just let us know where you're joining in from. Excited to hear, and it's always fun to see where people are coming in from all over the globe. On top of that, since we're kicking this off today, if you have not signed up for a Whereabouts account, you can do that. You can go to whereabouts.com and get signed up there on the community edition, or there's also we just kicked and launched off on the AWS Marketplace. So if you use AWS, there's an offer there to use the full suite of products and tools within Whereabouts, and an offer to use free credits as well. So that's up in the QR code in the upper section there. So with that, I'm excited to I'm going to bring on Mo and Gia here, just to kind of jump in and start that discussion. So yeah, Mo and Gia, welcome. And yeah, we're excited, obviously, to to announce all of this. I'll let you guys break the official news, which has been broken for kind of a few hours here. But yeah, yeah, why don't you gonna jump in and tell us a little bit about the news today, and what it means for you guys personally. Yeah.
Thanks a lot, Matt. I appreciate that you're giving us like a platform to talk about this today. And thanks to all your listeners. I know you have a lot of really enthusiastic listeners and followers in the geospatial and data and AI communities. So we're excited today to announce that we closed our Series A round. We raised $21.5 million from led by Felices, the team at Felices, and also continuous strong support from our existing investors, Clear and Wink, and also some participation from P7 and JetBlue. So we're very excited about this because we closed our seed round, which was $5.5 million, about like a couple of years back, and we were started back then. It was me and Gia, and we had the open source Apache Sedona that was already gaining a lot of traction, right? So this is how it started. But today things are different. We grew, I'd say, since Gia and I started 2 years back, we grew like over 1,000% in terms of team size, and we spent a lot of time building the team, building the product. We have a fantastic team today. I believe this is like a winner team, 100%. I mean, so everybody who's listening today, I expect a lot from this team. And we also been focusing a lot of building the product, doing a lot of integrations with the cloud, with the lake house, introducing a lot of concepts. So what we are trying to build eventually is we're trying to be the cloud platform for geo. So if you're doing any kind of geospatial analytics, ETL, data processing in the cloud, Wherobots should be your number one destination here and number one product. This is simply our mission today, and we're excited with the raise, with the raise this time that we're going to grow the team even bigger and bring this vision to fruition um, uh, within the next year or two. So I'm very excited myself. it's sometimes it feels surreal when you start and there's nothing and you only have two people, and now you have like a big team. You have a product, you have even fantastic customers. It's just phenomenal. So I'm humbled by everything here, by where by the stage we're at, by the team, and I'm looking forward to the future. So I'm gonna stop here and let Gia maybe share a little bit. If you have like a minute to share something, and then we can take it from there.
Thank you, Mo, and thanks, Matt, and thanks everybody in the room. And thank you guys for having us and listening to this exciting news. And I'm also very excited about news and very happy to see we received the funding and we can continue to build our product at Wherobots. And on the other hand, I also want to say this is really big news for the Apache Sedona community and also scalable spatial data processing for geospatial at large. Because at Whereabouts, we embrace open source at core, and we will continue to invest in the development of open source Apache Sedona and make sure everybody in the community can benefit from that. And we will also, of course, try to advocate uh, the greatness of geospatial data processing. And yep, that's it from me. Thank you, everybody.
Yeah, that's great. I mean, I did want to start because to kind of okay, to take a look back, right, to see how we got here, or how you guys got here. I mean, I'm the newbie. I've been here 2 months, so I've been along for the last little bit here. But let's rewind. I mean, I think Mo, you wrote a really nice post today, kind of walking through you know YouTube taking a chance to meet, kind of starting with GeoSpark at the time, and then taking it now to I think well over 2 million monthly downloads. Just as an open source project, that's no small feat, right? So walk me through kind of the initial you know idea starting with GeoSpark into Apache Sedona, and then how that's evolved into where we get to today, and what that means to lead up to where we are now.
100%, 100%. So it all started like I was a faculty member at Arizona State University, and I was starting my research lab at the university and thinking about projects that I should be working on, right? And back in the time, graduating with my PhD, where I worked in my PhD with my former PhD advisor, we had a few projects in the lab that we were focused on how can we do large scale geospatial data processing, right? And a lot of the efforts were focused on back in the time. If you guys, it's still relevant, but back in the time, Hadoop was the thing back then. But I was very convinced that systems like Hadoop had a lot of flaws in the architecture, based on again my training in computer science and computer systems in general, right? So studied that very deeply. So I thought about like again, how can we uh, build like something similar to Hadoop, but it's in memory spatial data processing. But at the same time, a system like Spark were coming into play and we're still getting started. I was attending like some of the talks of the Apache Spark people in the academic community. We had a lot of interesting. I saw the idea very interesting, and what I decided to do is I didn't want to reinvent the wheel. So I wanted to start from something like Spark and see how we can actually build something upon that to process geospatial data at scale. Back in the time, also, if you think the geospatial community were focused a lot on either the classic GIS tools, which are fantastic for whatever they built for, but nobody was, and most people that were doing the scalable or like again doing spatial data processing in the cloud, they were either using back in the time the data warehousing systems that did not have quite much support, using maybe PostGIS, and glue it into the cloud somehow, even though it's not like a distributed kind of scalable compute system or anything like this. But that was the state of the art back then. So we kind of developed GeoSpark. I met Gia. He was a PhD student. He came to me. I gave him a project like the GeoSpark project, and I told him let's build a prototype. And I was kind of putting, let's build a prototype in 3 months. And we built a prototype that did some kind of spatial join, spatial SQL functionality in 3 months. And we saw the results were actually phenomenal compared to the existing solutions. Even though, by the way, the code back then was buggy, was not robust at all that kind of stuff back in the early days, right? So this is how it started. So it started like that. We did a lot of research, we did a lot of benchmarks, we compared to a lot of systems, whether database systems, data warehousing systems, or like all of that stuff, right? So we did a lot of these benchmarks, we did a lot of scientific research into going to nitpicky details of how this works out. And we posted the first version of it on GitHub. And I'll be honest with everybody listening today. So we thought maybe 5, 10 people would find it useful and start using it or something like this, but the traction was like it went off, right? I mean, so it started with just a few hundreds and then a few thousands, and then the next year, like 100,000 people, like 100,000 downloads, and then fast forward to today, there are 2 million downloads. So apparently, there was a gap in the market, and Sedona filled that gap, even though Sedona did not solve all problems, right? But there was such a gap in the market that even with the few problems Sedona solved back then when it first started, or GeoSpark, people still used it. Even with the buggy code, even all of that stuff, they still used it regardless, right? Because there was so much need. So this is how it all started, and it joined the Apache like software foundation like about late 2020, something like this, in the incubator program. Graduated a couple years after, a year and a half after, and it has been taken off since then. So we provided spatial SQL and we provided spatial Python also integration, which also took off with the spatial SQL. And then the Apache community also made it much more robust, much more well maintained. The code now is being used in operational production and the most important use cases on the planet. Amazon last mile delivery, for example, they use the Sedona as the spatial data infrastructure. There are a couple of other kind of Fortune 500 companies that are using it in very, very important use cases that impacts our day-to-day life. So this is how it started, how it evolved, and this is one of the biggest reason we're here today, right? We definitely faced a lot of challenges throughout the way. And a lot of people will come and start like we received a lot of criticism for some of the implementations of the Sedona early on, all that stuff. And I took it all positively too, and we both took it positively, G and I, and we used that as constructive criticism to build the product, maintain the project better, and enhance it as we go. So I wanted to summarize this in a few minutes. I don't want to take much of your time, but if you have any other comments or something like this, we can definitely follow up.
Yeah, drop any questions you have at any time. Gia, what was the impact of getting it into the Apache Software Foundation, and kind of what's that community done for the project over time?
Yeah, that's a great question. So I think joining the Apache Software Foundation actually great contribute to our traction. So, but on the other hand, so there is a very high bar for a project to enter the Apache Software Foundation. So it is not like you any kind of open source software can go into the Apache, right? You need to go through a rigorous selection process, and you need to be sure that the project can grow, right? So after joining the Apache Software Foundation, after the incubation process, right? So I think this give us a couple important addition to the community. First, it gives us traction, but on the other hand, it actually makes the project, this entire open source project, more mature, meaning that it has very mature management structure, meaning that it has a strong committee that manage and steer the growth of the community. And on the other hand, it also defines how the community members, like contributors and users, how would they be communicating this community. I think all these things adding together give us the great opportunity and to grow the Apache software, Apache Sedona. Yep, I think that's a great thing for us.
Yeah, and I think what's so unique about, kind of where things are going to go is, I mean, at the core, it's still Sedona. It's still open source. It's still all these things that you just mentioned and talked about. There's still the community, kind of driving where we're going. And I think it's reflected in the diversity of, just spatial functions that are already in the project. I mean, one of the nicest things for me has just been the ability to work with raster and vector data easily in one place, in one set of code, and not have to like move around or pull different things in. Like that's been really nice. And obviously kind of what Wherobots is bringing, there's obviously the unified experience for a developer, someone writing the code, everything like that. But then the ability to scale and grow, plus all the added functionality, I think is something important. And I as we go, my plan is to do more of these live streams to get into these concepts, because there's no way to break all these down in one day, from distributed computing and why that works and why it works well with Spark and all these different pieces, why spatial was kind of like, why Sedona needed to come about in the first place, and add into that, talking about Apache Iceberg and what what Wherobots has already done with the project in terms of Havasu tables and supporting geometry. I mean, it's been just really nice for me to work with that in the past 2 months and go from there. Some of the raster inference, I mean, there's a ton of things we can go into and get from there. But I think, I will spend some time going into the specifics of those and getting in the weeds of all the individual pieces over time. So with that, and to set the stage, like what's next? Like, there's obviously the amazing teams I worked with for the fundraising have seen something in where we're going. Let paint the picture for the future of like, what's coming up, what features and things we want to work on. Get into the weeds of like what people should expect from us, coming forward. So
Yeah, I mean, there's a lot. I mean, we have a lot on our plate, right? A lot in the roadmap. I'm excited for that roadmap and for the vision ahead. But I want to emphasize that, and I don't want to forget what made actually us successful in the first place and what made Sedona successful in the first place, right? And this is how, this is what still defines the vision too. So the number one thing is like, as I said, what made Sedona actually took off, for instance, is it's not necessarily the spatial functionality per se, right? So it's or alone. The spatial functionality was needed, but it's how you integrated the spatial functionality into the data stack, into the data ecosystem that people are using in data teams day to day, right? So, I mean, that's basically one of the main reasons that Sedona took off. Sedona did not ask people to go and download a different software somewhere else or something like this, or have a whatever, a desktop or a different kind of website. It's you're working in your data stack, data analytics pipeline, or data processing pipeline. Sedona was brought to you where you are. And that's actually one of the main things that made Sedona actually very, very attractive for folks. So there are a lot of, for example, there are millions of SQL developers out there. So these SQL developers are working in Fortune, like whatever, 3,000 companies. They're building data engineering, data processing pipelines, and they need geospatial within that, because geospatial, as we all know, is everywhere, right? So Sedona made that happen. So it brought that to them instead of just asking them to go and deal with a specific, completely different stack that has geospatial functionality. So that's something I don't want to forget that. And the other thing is Sedona made it enable in the open data architecture. You mentioned Iceberg, Delta Lake. You mentioned like all of this. What the data ecosystem is going to is the open data architecture, and basically, uh, organizations are going to have one layer, one source of truth for the data of the data in like an Iceberg or in a lake house or a data lake, and they would want to bring compute, special purpose compute that is efficient, higher value, lower cost, that runs on top of that data for specific applications, for specific use cases. So Sedona played into that, and Wherobots is building upon that even bigger. So that's basically what it is. How you can be integrated, naturally integrated into data and AI ecosystem, and at the same time do this with higher value, lower cost, and provide support for, in other words, bring geospatial functionality or to the masses of data and AI practitioners out there instead of asking them to come to something new or try. Like, I mean, so this is basically one of our biggest contribution, and this is how we're going to make uh, geospatial less of a niche, right? You're going to make it more mainstream that way, as opposed to insisting on building, let's say, like a map-centric solution outside completely the data stack or something like this. That's something that Wherobots is bringing. That said, we still also very easily integrate it into the classic GIS, classic map solutions or even modern map solutions out there, because we still think these tools are still necessary, and there are applications that need these tools as well. So it's that kind of mix that makes, I think, Wherobots, Sedona first, and then Wherobots also very special. And this is what we are going to be building upon, generally speaking, in the next couple of years.
Yeah, I mean, even into the core elements that I think extend what Sedona is. I mean, and I think that looking at the pieces like Iceberg, some of the raster inference technology, and the things we're bringing to the table there, all of that is still open at the core, right? I mean, we're talking about the Apache Iceberg, basically kind of helping you build a spatial lake house, right? That really didn't exist before, right? That's purpose built for geospatial. That's one piece, but the goal is to bring that back into Iceberg and go from there. Raster inference, we're using open models and kind of adapting them to some different pieces, but that allows you to scale. And the compute layer, the processing layer that's built just for geospatial helps you scale there. And I think, you know, uh, I guess a question for Gia is, all of those pieces that we're bringing to the table and having them at the open core, why does that help us scale so much more? I mean, that's always, I think, a question when people ask, like, there's these kind of open core type of tools. And I don't know if that's the right exact term, but we're committed to that. Why, I guess why? And what does that mean for our growth, and how does that help us?
Yeah, I think that's a great question. I believe the importance of having open core and open source software is to break the data silos. In particular, this is important for geospatial data. So in the past few decades actually, so if you look at the geospatial industry, right? So most of the developers and practitioners just stopped at traditional tools, desktop tools, and old school tools, right? And all the data stored in commercial formats, in tons of different formats. It is extremely hard for geospatial practitioners to exchange data, to make sense of their data, and also in particular to analyze data at scale. So I believe with the embrace of the open core, like adding geospatial to Apache Iceberg and adopting the geospatial data lakehouse architecture at Wherobots, so this will actually help us break the geospatial data silos, and this will make geospatial no longer special. Yeah, that's the vision here. Thank you, Matt.
Yeah, I know that term. Like, it always kind of, going back to like when I was learning, like spatial is this special thing that needs to get treated. Like, the more we bring it to other people and make it more accessible for everyone working with data, that's a good thing, right? I mean, like that's what we want to do at the end of the day. And the whole way I've kind of been thinking about things over the past few years is that interoperability, both from a technology level, the whole point of that is to enable better collaboration with everybody around you, and we learn better together rather than kind of putting ourselves kind of in separate places. So, and it's cool because I like talking about that from a technology level, but I mean, I'm excited to see the impacts of what that really means working with it and doing those things. And of course, it's better to hear from someone else actually doing it than just us telling you. So I want to, introduce John. John's here from Address Cloud, and he uses Sedona, and John, I've known you for some time now, and you've been doing this type of work for a long time on massive scale. So, but I'll let you introduce yourself. Just kind of give who are you? Why are you here? Yeah.
Okay, hi, I'm John Powell. I'm a data engineer. I work for an SME. We're not a startup anymore, based out of the UK in the insurance sector. So basically what we do is if you send us an address, we'll geocode it for you. That's another very complicated problem. And then we will return lots of information about that address in tens of microseconds into the underwriting market. So typically that's the stuff I work on, particularly are perils. So hurricanes, floods, landslides, all of these bad things that can happen. And we also provide sort of rebuild costs and roof materials and other things about the building. So large scale geospatial processing problems, basically.
Yeah, yeah. And so you've been using Sedona Wherobots for some time now. Give me like a before and after picture. Like, what were you doing before, and then what did
Well,
that look like after the fact?
if we go back to the late Cretaceous, I studied on ArcView like everyone else, but then there was that big wow moment where I discovered sort of PostJS and everything was happy and hunky dory, and I learned spatial SQL, and it's like, I've got all this power at my fingertips. And then following on a few more years, the data just got bigger, more countries, higher density, temporally and spatially, and just what was being asked of was becoming more and more problematic with PostJS, because after all, it's a ACID compliant RDBMS. It's not designed for parallelization and scaling in the way that Spark and Sedona are. So following up from that, I discovered BigQuery, which is fantastic. It's serverless. You don't have as much control as you do with Spark, but it crunches through things a lot quicker than PostJS, but it doesn't support raster. And a lot of my work is raster based. So then that led to, gnarly workflows of having to vectorize the rasters using, GDAL polygonite. You're smiling
Yeah,
because
yep,
we've been through this together. Yeah.
yeah,
Data flow and all those kind of fun things.
yep,
And ultimately, it's a pretty fragile workflow, and you end up with massive data volumes too, because of course TIFFs are compressed, and once you vectorize them, they blow up massively.
right,
So even though PostGIS and BigQuery are great tools, they break in. They don't have this sort of clean flow like you get in Apache Sedona or Wherobots.
yeah,
And I think, as Mo's already touched on, the data, it doesn't matter if it's a shape file, a GeoTIFF, Parquet, GeoParquet, it's all just sitting in an S3 buckets. You just start writing the code,
right,
and you don't have to worry about the format beforehand. So
right.
that's revolutionary.
Yeah. So I think I mean, I feel like I'm picturing a meme here, where is that like, evolution of like someone's brain exploding, getting smarter, or basically like you start on GIS, you see something, a shapefile for the first time, you're like, wow, this is amazing.
Wow. Yeah.
Like I remember that moment. You go up, you put something in a database, and you're like, wow, I can change it with just writing this, amazing. And then you get to this like bigger system, and then you like you're kind of like, you to work everything together. I feel like, I'm kind of like patching this thing here, duct taping this on, pulling it together. Um, the specific problem you pointed out is that combination of working with raster and vector right in the same place alongside each other. And that was one of the big aha moments for me. Can you like describe what that change has done or enabled you to do in your work, and like what are the nice parts about it that make it so seamless?
Well, like as I said initially, apart from the data just already being in S3 and not needing transformation, it's also that ability to just immediately choose a compute size for the job, the appropriate job, not have to worry about Kubernetes and all the glue or any of these other things, because we could do that, but we're a small company, and so you outsource that. So really, the first time I sat down and I did a tiny little area of California, and I ran it on one of your small instances, like, this is great. Let's try a big one. Let's do the whole US on a 10-meter grid against individual buildings. Really a chunky job.
Mm,
And I did it on a large, I think it used to be called Cairo, much more fun name, but and then it ran in a few minutes, and I literally almost fell off my chair. It
yeah,
was one of those, aha moments without
yeah,
transforming anything. Yeah, just mind blowing, actually. So yeah, it was,
yeah,
like you say.
yeah. And it's I mean, I that was, I think it feels like there's this whole like wrestling match sometimes you have to do with like, you know, raster. I mean, and of course like PostGIS supports raster and you can do a ton of those types there, but taking that into distributed setting and scaling that. And then even more so, and this is the thing that like kind of blew my mind was, you know, okay, there's a lot of good open data in a lot of places, specifically cloud buckets. So you have S3 large collections of open raster data that's sitting right there to use, right? Now to use that, you might have to actually physically download and get everything in and connect to it and go from there. Now I'm just what's really nice about this concept of like we're getting in the weeds now, but like an out of database raster, I can actually read that and point to that without moving any data. And when I run my query, I just take the little bits that I need to. And you get all the control of the optimizations and pushing that down from the compute side. So, I mean, what were there other like specific like challenges or things from the workflow side that were like made easier when you moved into Sedona Wherobots and went from there?
Well, obviously having the prior the prior experience with spatial SQL and having used the kind of, you know, NumPy, PyTorch, whatever. If you know basic Python, you've worked with notebooks and you know spatial SQL, it's a pretty easy shift. Obviously, there's a lot of different mechanics in Spark under the hood. There's a lot of things to optimize, but actually it's quite an easy move if you have that skill set, and lots of people do. And of course, the other amazing thing is that your source code is open, so you can read it, and it's very nice. And also, if I have a problem, I say so, and 2 hours later, someone comes on and, you know, tells me how to optimize it. So that's also a really nice experience.
Yeah. And then the ability, I mean, like one thing that, so I mean, I remember my first like kind of when I was playing around with Sedona a while back, like probably a couple of years ago. I mean, just, you know, I knew what the limits of where I could go, right? I could pull it in a Docker container, I can write the code, I can test some things out, but Spark is a distributed computing system, right? I'm going to have to like connect to Spark and do all of that or maintain it, or like you said, all the Kubernetes pieces. These are areas that, I mean, I can pull a basic Docker container and do some things like that. But like once you get into the scale out kind of perspective, like that's where I'm like, that's, you know, a no-go zone for me. So I know what I could get there and I could see how it could all connect, but then like now you just flip it on and go from there. Can you talk about like that shift from, you know, self-managed infrastructure to managed infrastructure and what that change looked like?
Yeah, I mean, you've hit the nail on the head. Not having to do that stuff, because we were talking internally about shall we do this, you know, and building glue jobs to do this kind of thing. And at the end of the day, at this sort of outsourcing compute and sysadmin is part of the whole cloud revolution, in my opinion. It's not often talked about. People talk about cost, but really, not to have to do those gnarly Kubernetes type things is really valuable as well. And, you know, 5 minutes, I click a button, choose the compute, and I'm ready to go. And when it's all done, you know, if you remember to turn it off, which I forgot to do once, then you know, it's all turned off. Nothing more to worry about. So yeah, it's just an incredibly productive environment to work in.
Yeah.
You know, I have tried running Sedona on Databricks, you know, to be honest, and it works, but it's not nearly as performant. And, you know, yeah, I don't have any more comments on that. It's it's literally
yeah, that works. And then I think, you know, last question is like, you know, what else do you want to like? What are you looking forward to in the future?
I've already used your k-nearest neighbor join, which is another pretty painful, can get quite painful on large data sets. And I've also got a really fun use case for ClusterDB scan, which you've also just released. Raster inference is also of interest. So yeah, we got plenty of things in the pipeline for which Wherobots will be a very good fit.
Nice. Yeah, very good.
So,
awesome.
Like you, I've been watching it for a long time, and it was the raster vector that drew me in. But there's a whole lot more there than just raster vector.
Yeah, awesome. Well, I'm gonna bring everyone back on here, just to kind of, you know, number one, I guess, if Mo and G, if you have anything for John that you wanted to ask, I'll let you do that. And then, you know, if there are any extra questions on the end, make sure to drop those in the comments, be it YouTube, LinkedIn, wherever you're watching from. We can jump into those, and then, but yeah, I'll open it up here a little bit.
John, just I want to say this. Thank you very much.
Yeah. Thank you. You're very welcome. Yeah.
Yeah.
You've assembled quite some team there.
See, it's the Avengers over here. We're just, adding our pieces. So I guess I see a few kind of comments and questions that have dropped in. One is like, kind of, there's been a lot of talk around cloud native geospatial. All these, obviously, Jed drafted me in to be on the CNG editorial board. Where's cloud native? I mean, I think we're driving cloud native, right? And I think we're using a lot of these pieces, but like, what do you see as like some of those critical cloud native pieces, and like, why is that enabling things for geospatial to grow?
I can take this. So I think the cloud native concept matters a lot for the geospatial industry. So first of all, so I think cloud native geospatial per se, meaning that you need to have at first of all, the data should be large. You need to assume the data is large, and the data processing tools should be able to only download a small percent of data based on what the user need, right? So the data format and data tools should be able to support that. And on the other hand, the data format itself also needs to be open, meaning that so the data format, how the data is stored, how the data is encoded in the format needs to be clearly defined and open to the public. So that way, this will enable people to freely exchange the data among different parties. So thirdly, so I believe the data lakehouse is also very important for the cloud native geospatial industry. This is because data lakehouse, meaning that you need to decouple storage and compute. And you can use, as a user, you can bring in any data as you want in any kind of format. You can hook up it with any kind of data processing tools and compute engine. So this will make everything scalable, and you can have all different solutions plug and play. Yes, that's my point of view.
Yeah, the decoupling of storage and compute is like, I mean, it's weird that we don't think of. I mean, it's logical when you think about it. And I was just last week at North Carolina State for their GIS week event. They had a full week down there, which was great. And I think we got into the weeds of like why that's important. And you can have your storage can be as big as you need it to be, and then the compute you bring there, and that can scale also as you need to. If you just need a little bit for the one operation, great, and you're good to go. And if you need to go up, you can from there. And then that ability to move very quickly is amazing. And then just, I guess, earlier that week, I did a webinar where we took some tables that I had produced in Havasu or Iceberg and pulled those into Snowflake, and they are their QGIS connection, and just happened like that. I didn't have to move any data. My data just sat there, and it's already in table infrastructure. And the connection took about like 3 seconds once it was there. So there's a ton of things there, which was great.
You nailed it, man. I mean, so separation of the biggest kind of benefit of separation of compute and storage is enabling the cloud 100%. It's not because if you think about the cloud, the main thing that defines the cloud is both on the technical side is elastic compute, elastic storage, and on the business side is the elastic pricing, right? And if you cannot have that separation, it's really hard to achieve either of them.
Yeah.
So that's definitely, I mean, one of the biggest thing, and that's why this is one of the main pillars of the design of the Wherobots product in general. The second thing is obviously the elastics, like the open data architecture and the lakehouse architecture is definitely another kind of design pillar, which makes it much more available in the cloud, much easily. The data that is being stored there much easily accessible, as you mentioned, everywhere. It doesn't have to be like even if it was created in Wherobots, the data or processed, you can access it through Snowflake, through DuckDB, through other mapping kind of Python libraries that, or kind of JavaScript libraries that are used in mapping kind of interfaces and stuff like this. This is the interoperability part, and bringing it to the cloud is going to actually enable all of that. So you nailed it, man. I mean, 100% on board here, and yeah, I'm gonna stop here, but I just wanted to emphasize this point.
Yeah, definitely. Yeah, I agree 100%. I mean, Iceberg's been a big bonus, and expect to hear lots more about that. I did have a couple questions that came in. So it looks like someone from the Cartoza team. I believe you're in South Africa, and you guys do a lot of amazing open source work, and so kudos to you guys for I've seen a ton of your stuff, especially the Docker containers, which is great. But question being, why did you choose AWS over other cloud providers as the infrastructure and cloud platform? Quick caveat before we get into that. We will be at AWS reInvent next week. So that's in Las Vegas in December 2nd through 5th or 6th. It's a full week. But if you're there, make sure to find us. We're hosting or co-hosting a geospatial event on the 4th with Cardo, actually. So we're kind of doing a co-hosted event there. So if you're into geospatial and you're in AWS, swing by and we'll see you there. But yeah, Mo, I'll kick that question your way on the AWS side.
Yeah, I mean, we choose AWS. AWS is pretty much the very first cloud, is the largest kind of cloud provider out there. So we chose to be on AWS because primarily because of that. So we partner today. We're an AWS partner, working closely with their team to bring the Sedona and geospatial data processing capability to AWS existing AWS customers. So that's one main reason. That said, though, we like again depending on how what our customer need, we might actually be bringing Wherobots into other kind of cloud providers as well, other than on top of AWS. But we are primarily now on AWS, and we're so excited about this partnership. AWS is fantastic, and as Matt mentioned, we're going to be next week at AWS reInvent, and we have a party. So if you're at AWS reInvent or in Vegas by any chance, please stop by.
Yeah, definitely.
Yeah.
Yeah. Another question, more about the geostats package. Yeah, geostats is another piece that we've been adding in, and I've just started to scratch the surface. But I mean, John, you mentioned it from DB Scan. I think there's some Getis or G Star, some of those like kind of spatial statistical components. Where are we going with that?
So the geostats package is accurate, another great evidence showing that Wherobots is still contributing back to the open source and the community. So we recently donated our geostats package from Wherobots to Apache Sedona community. And geostats is a scalable spatial statistic toolbox that enable people to do all sorts of interesting spatial analytics functions, including DB scan, outlier detection, hotspot analysis, so on and so forth. So in the future, we're going to continue to invest in this package. In particular, we're going to put the entire package open source in Apache Sedona. So in the future, we have a bunch of new functions on the pipeline that includes, for example, collocation pattern mining and autocorrelation, this kind of statistics tools. And it's going to be continue to be really useful for the community. And we are also welcoming any kind of feedback to the community. Thank you.
Yeah.
And I mean, I want to emphasize one thing about this is like these algorithms and already existed before, right? Either in Python libraries or other kind of systems. But the main difference is that these in Wherobots, these kind of geostatistical algorithms are going to be massively parallelized, embarrassingly scalable, right? I mean, so no matter what the size of the data set is, no matter what the size of the computation is, and that's actually what is the main difference of when you start using these. So this is just like again clarifying this part.
I'm just confirming you said embarrassingly scalable. Is that that's a new
Yes.
term? Like I think like I've never even I don't know if anyone has coined that one before, but I mean we're taking it now. So I'm embarrassingly scalable. I like that. Nice. Another question here. So raster seems to be primarily supported as of now. And of course we support vector data as well. And I kind of mentioned that vector alongside. What other formats do you plan to support? Yeah.
So I can take that. So for the new data formats, so in the future, we are looking at two major directions. So one direction is we want to continue to invest in more on the climate and weather data side. That means we want to support not only just weather data alone, we will also want to support like array type of data, multi-dimension data. So that is one side. And on the other hand, we also want to continue to invest in the mobility data set. That means in addition to the traditional vector data, we supported polygon points. We also want to support traffic data, for example, trajectory data. We want to support scalable analysis and scalable algorithm, such as map matching on this kind of traffic and trajectory data. Yep.
Yeah. No,
Another
go ahead,
another
Mo.
thing I want to say is definitely like kind of there is a lot of climate and data is stored in arrays like ZARs and stuff like this. So this is also another thing that is coming up. Support for that, both in the open source and the and Wherobots as well. So I want to. This is really important, especially if you want to integrate climate data with your vector data or something like this, which there are so many applications to that as well. So this is also coming up. And yeah, plus, I mean, there will be also like kind of integration with existing vector data formats. We support a lot of them, but there are still some that we need to get underway as well. So this is also something that is coming up very soon.
Awesome. Well, great. Yeah, I think those are the core questions we had for today. So first of all, I thank you, Gia, Mo, John, for all taking the time to hop on and discuss. As I said, I plan on, I took a little pause on the live streams, but I think, today was a good day to like kind of kick this off. And I think, to look forward to is having a few of these, diving into things like this that I think are really important to, break apart from the concepts that we just talked about: distributed computing, um, understanding, separation of storage and compute, raster vector, developer experience, all these different pieces that I want to dig into a little bit more. So going forward, I'll be pushing those out so we can do some more of these like kind of mini bite-sized tutorials and get some of this information out there to help you scale and take this into other parts. I mean, beyond what we're just doing with Sedona, working with GeoParquet, working with Iceberg, working with all these tools and bringing them into whatever workflow you're working on. I hope that can be really supportive for anything you're doing across the geospatial space and from the community side. So yeah, I'm thank you again for joining. Very exciting day. If obviously, I think I have the links up here if you want to sign up and get started. Try out Wherobots today. If you are on AWS or if you plan to use AWS, there's an offer for you to use some free credits, $400 free credits from Wherobots to get started with our compute infrastructure. So definitely make sure to take advantage of that. I'll flash that one up here if you want to check that out and see how, quote, embarrassingly scalable Wherobots is to use and go from there. So yeah, once again, thank you everyone for taking the time. Thanks for kind of taking a break to learn and celebrate with us. GMO, congrats again. John, thanks for taking the time. I know it's getting later on your end there, so I appreciate it. And yeah, thanks everyone, and I'll see you next time.